I mean, you will not believe what just happened. My MCP client, this Claude desktop, actually created a complete social media calendar for my social media agency in Notion directly. Okay, I just put a prompt that, hey, prepare a social media calendar for my social media agency, ABC Media, and we create content on LinkedIn, Instagram, and Twitter. Create a balanced social media calendar for every week, and put this calendar on my Notion. And this MCP client had access to my Notion as an MCP server, which is running locally, and it directly put the content on my Notion. And you will not believe that it has created a weekly content calendar. So if I go inside it, you can see the content titles are there, categories are there, like news updates, content engagement, video content, reels, image post, polls, text post, days on which I have to post, notes for every post, platform status. So this is like one example that we're going to do, like we are going to build in this video tutorial, complete video tutorial. But just imagine the impact of this MCP. I mean, within 10 minutes, we actually built this. We did not build this. We used open source Notion MCP server, but within 10 minutes, it was possible for us to give access of our Notion to our MCP client, which is running, right? And for now, I just gave one MCP server as a tool to this MCP client. Imagine if I give it access of my Google Drive, my Google Sheets, my Google Docs, then my GitHub, my Slack. It can actually act as a Jarvis. And from this Claude desktop window itself, I can control all of these softwares. I can just say, hey, write this piece of code, write this software, and push it to GitHub. It will automatically create beautiful commit messages, and it will create issues on GitHub. It will create pull requests on GitHub automatically. And if I'll say that, hey, send this message to my peer on Slack, if it has access to Slack MCP server, it can do that. I can ask this Claude desktop to book a meeting with my client and send the invitation on mail. It will get access to my Google Mail, like Gmail, and my Google Meet, and it will book a meeting for me. I don't have to leave this Claude desktop. So all of this is possible like without MCP also. I mean, you can create tools for it. You can code tools for it. But with the help of MCP, it has got standardized. And that complete thing we are going to explore in this video. But before that, you should know that who am I, because I'm creating this tutorial and you'll be watching me for the next 1 hour. So you should know who am I and what I have done. So I work as a developer relations engineer at Maxim AI. We excel at agent simulation, observability, and evaluation. So we have been working in this AI agent space for quite a long time, and we recently explored MCP and we found the potential, and that's why we thought to create this complete tutorial. So here I am teaching you. Before this, I was a founding engineer at an AI SaaS, and as you can see on my channel also, I already have around 60 to 70 videos on data science, Python, NLP, and ML. Apart from this, I also have a Discord channel, Discord server, where you can join. And if you have any doubts, you can feel free to reach out to me over here. And we discuss, we solve doubts, and there are some opportunities, announcement, resources sections also. Okay, so let's get started. So you already know that Model Context Protocol is by Anthropic. The whole SDK, the whole protocol is built by Anthropic, and they have built some example servers, MCP servers and MCP clients around it. And the whole thing is open source, so other developers, other companies, even the big companies can build their own MCP servers and publish them. Even OpenAI or some other big techs also have built their open source MCP servers already, and they have put out Agent SDK, which is by OpenAI, has their own MCP server launched recently, couple of days back, so that agent builders can directly talk to the MCP server, and they can build the agent very smoothly without worrying about the underlying implementation of the tool calls or prompt templates and all of those things, right? So I know this can be a bit tricky for you to understand at this point of time, but as we move forward and we understand why MCP, what is MCP, what is the problem that MCP is solving, then it will become very easy for you to understand it. And for this complete tutorial, I'll be referring the official Model Context Protocol documentation. And after this video, you don't even have to worry about the docs, because during this tutorial, we'll almost cover this complete docs, and you will see how to actually go through this docs also, the correct way. Okay, so we'll be referring this documentation. Next is understanding the problem, like what exactly is the problem that MCP is trying to solve, right? Because this is a complete protocol, right? MCP is trying to not change, but actually focusing on improving the experience of the agent builder, right? Because the problem is, if today you have to build an agent, let's say you are an agent builder and you have to build an agent, and let's say you have a user in your system, Okay, and that user wants to communicate with your agent, and let's say you have built an agent over here, right? And let's say this is an agent which can which can go through the resumes, right? It's a resume or it's a hiring agent. Let's call it as HR agent, right? This agent has capability to go through resumes, take the job description, and find out which candidates are the best suited for that job role, right? And it can go to the internet. It can also like look for better candidates on LinkedIn or other portals, right? Or other profiles. So this HR agent will have certain tools, and definitely it will have a connection with your LLM, right? Which is going to be the brain of your complete agentic system, right? This LLM can be GPT-4o, it can be Gemini Flash, it can be a Grok model, it can be anything. So this agent is connected to an LLM, and this agent is also connected to some tools, right? This agent is connected to some tools. Those tools can be internet search tool, right? On internet, this agent can find out some candidates, so internet search tool, right? This tool can be PDF reading tool, because at the end resumes will be in the form of PDFs. So this agent should have a capability of reading PDFs, right? And this agent should be able to present us the final candidates list. So if I want to get the list, I want to get it in the form of a JSON or in the form of a markdown or anything. So basically this agent is an autonomous agent. It can do stuff on its own. It can make decisions on its own using the LLM as intelligence, and it can find out which tool is actually required at a particular instance for a particular call. Let's say your user is coming to the agent, and it is asking the agent to find the best candidates for a web development role, right? As soon as this agent gets this query, this agent should be able to make a call, make a intelligent call that, hey, first of all, I need to find the candidates. Or even before that, the first step should be to get the job description ready. Like what is the salary, what is the experience required, or where is the location, is it a part-time, is it a full-time contract, right? So get the JD ready, right? So this JD, agent can ask the user to provide the JD. That can be one way. Or it can take that job role, and it can go on the internet using the internet search tool, and it can find out which all job descriptions are already there, and it can take some reference and create a draft of it. The best way will be to ask the JD from the user itself. So over here, this agent made a call to the LLM, and LLM told the agent that, hey, ask the user to provide the JD, right? Or another response from LLM will be to make a tool call to search the internet of same job descriptions, same job roles, and draft a JD, right? So first step should be to get the JD ready. Next step should be to use the internet search tool to find the candidates, right? Go on LinkedIn, go on Wellfound, go on other portals, and bring the candidates, right? So this was the another decision that was made, and that decision was to make a tool call, and agent made a tool call using internet, and maybe using Tavily or any other tool. Internet found some candidates and gave it back to the agents, and using that list of candidates that it got in an unstructured format, agent framed a JSON, or agent formed a list of candidates with skill set, with current salaries or current location, and gave it to the user, right? And definitely it matched with the JD. So JD getting matched with the resumes, right? And finally the fourth step will be to provide the candidates, list to user. And then this is how the agent completed the task end to end. So during this process, agent had to make the tool calls, right? And when the agent the tool calls, or the agent had to go back to the LLM to get the data in the required format. And for that, the agent had to provide the context to the LLM. And over here, on this context itself, this context is the main thing. And on this context itself, this whole model context protocol is built. Like the requirement, the inspiration, or the problem is coming over here itself. Context, that is one. So first problem is your context, and next is the implementation of these tool calls. And third can be even the prompts, because at the end, when you are going to the LLM, you're going ahead with the prompt, and with that prompt, the context will be there, right? And based on the response, you will be making a tool call, right? And most of the times, these tool calls will be, can be, let's say you got the list of candidates, right? Let me just get some space, make some space. So let's say you got the list of candidates and now you want to save those candidates in a database, right? That can be one thing. Or you want to save that list of candidates in your file system, in your computer, so that you can send it to your manager or your HR, right? So there can be two ways. Either you want to save that final output in, you want to save that list in file system, or you want to save that in a database, in a remote database. That can be Postgres, that can be like MongoDB or anything, right? So these can be two things. Or when you are making the tool call, let's say you already had a system, let's say you had a service which can give you the correct JD, or which can give you the which can actually match JDs and resumes. So I can say third party service that can actually match resumes and JD. So if you give resume and JD to this third party service, it can find the score, right? So third party service. So I can say that when you're making an agent, you will be working with various resources. Those resources can be remote or local databases. MongoDB, Postgres, they can be either remotely deployed or locally deployed. So remote and local databases, right? So I can say remote or local databases. Second thing can be your file system. When, let's say, you already have a list of resumes in your computer in a zip file, right? And you want your agent to just pick that zip file and find the scores, matching scores, right? So you will be working with this file system also, your computer file system. Third thing can be your third party services. Let's say you are making a software development agent. Your agent can write code. So at the end, you would like your code to be pushed to GitHub, right? So how will that be done? So you want your agent to do it because you are building an autonomous agent, right? So for that, your agent should have a capability to talk to GitHub and send that code to GitHub. So third party services. Next thing can be your computer use. So this term is by OpenAI, but computer use. Let's say you want your agent to take control of your computer. Let's say it can automatically open the browser, it can search something, it can detect something, and it can shop, it can do shopping on behalf of you. So you want your agent to take control of your computer and, like Jarvis, and it can handle your computer on your own. So that can also be done, right? So for all of this, let's say you're building an agent today, right? So for all of this, you have to create your own APIs, right? You have to implement these things. Let's say today you are building a software development agent and you want your code to be pushed to GitHub. So you have to understand how GitHub API documentation is, right? You have to understand the whole APIs, all the API contracts, and then you have to write your own tool, right? You at the end, you'll be making a tool, right? Which agent can communicate with or call, right? So you will have to make a GitHub tool. Then let's say you want to push a notification to Slack that, hey, my code is pushed. So then you have to understand Slack API contract, Slack API documentation, and you have to write a tool for Slack. Second, now let's say you are working with remote and local databases. Now today, let's say you have MongoDB. So you have to understand how MongoDB integration works, and you have to make a tool out of it, right? So that your agent can call that tool and in data can be saved in MongoDB. But now suddenly you switch to PostgreSQL. So again, you have to do the same thing. You have to create a tool for PostgreSQL and again put it in integrate in your agent, right? Then how will you do this computer use, right? How can you make an agent that can control your computer? Because at every point of time, your screen should be sent to the LLM and it can make decisions. This is also tricky. Third party services, there can be Slack, browser based, GitHub, Notion, or like thousands of APIs can be there which you want your agent to communicate with, right? So for all of that, will you go ahead and read their documentation and create a tool? Let's say you did this for one company. Now you switch the company as an agent development, or we are now working with another client. So will you do the same thing there? Will you again create the tool there with some modifications? It is so tricky, right? It is so hard. And this complete thing was becoming a headache for all the agent builders. So that's when Anthropic came into picture and they created a standardized protocol called Model Context Protocol, right? Which helps us to easily work with context, tool calls, prompt templates, and many other resources, many third-party resources. We'll come to the architecture of MCP. Now you know what is the problem that MCP is trying to solve. Inspiration is language server protocol, right? So what is language server protocol? So if you check Wikipedia, Wikipedia says language server protocol is an open JSON RPC based protocol for use between source code editors or integrated development IDEs. You know IDEs, right? So you already know what an IDE is, right? What an IDE is, integrated development environment, like Visual Studio Code, or it can be Sublime, right? It can be Atom, it can be Android Studio, right? So these are IDEs, integrated development environment, where you write code. So we are now talking about software development, right? Where you write code, IDEs. So in these IDEs, you must have experienced autocomplete, right? When you write something and it can automatically complete your code, you must have experienced it, right? And when you make a spelling mistake, syntax errors, it can also detect those syntax errors. It can automatically mark that word, like underline it and mark it with red. So syntax errors. So how is it happening? How is this thing possible? So there is a language server protocol in the backend of these IDEs, right? And Visual Studio Code, Microsoft actually made this concept of language server protocol, and it works on JSON RPC, remote procedure call, right? MCP works on JSON RPC 2.0, JSON 2.0, right? And this LSP works on JSON RPC 1, JSON RPC, normal one, okay? So IDEs communicate with LSP, right? And when you are writing something, it sends that complete code as a context to this LSP, and this LSP can autocomplete it or find errors, or it can find syntax errors, right? Error handling and all of that, right? So LSP was doing this. Now I'm not saying that MCP cannot replace LSP, right? MCP is not a solution or an improvement of LSP. No, LSP has its own significance, and it will exist. It is not going anywhere. MCP just took an inspiration from this system, that hey, the code was sent as a context to LSP, and LSP did something at the backend. It was able to suggest the further code to the developers. So LSP was already existing. Microsoft and Visual Studio Code built it for their VS Code IDE, and using this as an inspiration, MCP came into picture. Okay, this is what is given in their official documentation. So now you know LSP, which is an inspiration for MCP. Now what is MCP? For this, I would like to go on the official documentation. MCP is an open protocol that standardizes how applications provide context to LLMs. We have already seen this. Think of MCP like a USB-C port for AI applications. Let's come back to our example. So over here, I'm saying that, like when I told you that, hey, if you change the client or if you change the company, again, you have to make that tool call, right? With some modifications. MCP solves that. So what MCP does is, and definitely we're going to cover it in the architecture. What MCP does is, let's say you have a client, MCP client, right? So this MCP client means where you chat, right? Where you actually get a chat window, or from where you as a end user can communicate with the whole agentic architecture. So this is an MCP client, right? Then MCP servers stick over here, and this MCP server can be of various third-party service or various resource, right? This MCP server can be of Notion, right? This MCP server can be of GitHub, which GitHub built it for the developer community, for the AI community. GitHub has officially created it, or some of their, some good open source developers built it, who already know how GitHub works end to end using their API documentation. Or it can be of Slack. This MCP server can be of accessing local files, right? Or this can be a custom MCP server which you build, which you have built on your own for your own logic. Let's say you built an MCP server to calculate compound interest. You are building a finance application and you built an MCP server for compound interest, right? So this MCP client can communicate with MCP server, and in this MCP server, at the end, this MCP server is communicating with the necessary tool. or with the necessary file, or with the necessary third-party service, Slack or GitHub, third party, right? So at the end, now I'm coming to the solution. Now, if you are changing the client, or if you're changing the company, or you're building another agent which needs some part of it, you can just pick this MCP server, which has no relation with your use case, and it's just a wrapper. It's just a like a bundle of the implementation of these tool calls, right? The APIs, like how to call this API, like let's say for GitHub, push code to GitHub API will be there. Commit code to GitHub will be one API, or pull code from GitHub can be one API, right? So all of those API logic is built in this MCP server. And now if you're changing your agent, if you're working on a different project, then you can work with another MCP client, and this whole system will easily be able to communicate with that MCP client. Like you have a CPU, and in that CPU you can plug USB cables, you can plug a mouse, you can plug a printer, you can plug a keyboard, you can plug any peripheral device, right? So that's how this MCP server, or this whole MCP, acts as a USB adapter. You can just pull in, you can just plug in anywhere. You can just pull it and plug it anywhere in any agentic architecture, right? So this is the beauty of this MCP, that it acts as a USB-C adapter, right? Coming back to the documentation, just as USB-C provides standardized way to connect your devices to various peripherals and accessories, MCP provides a standardized way to connect AI models to different data sources and tools. One MCP server can connect to GitHub. You just take that MCP server, fit in another agentic system. It will work without any issue, right? Because the whole logic is there in that MCP server, and now you can have any use case. You can have any use case for your agent. This MCP server will work, right? Great. Why MCP? So here is the answer of that. MCP helps you build agents and complex workflows on top of LLMs. You saw over here, my MCP server is not directly talking to LLM, right? It is built on top of the LLM. MCP server has the logic or the implementation of the tool call, of the resource that it has to communicate with, right? So it is isolated. It is isolated is not the correct term, but kind of it has to just take care about the task that is given to it. And at the end, it can communicate back with the client also. Let's say MCP server found something that, hey, this information is missing. Then it can go back to the client and ask for that information. So it is AI enabled server. Like normal servers, you say that, hey, I can build my own API calls, right? But those API calls are dumb, right? They will only do that thing that it is asked to do. Like there will be a fixed request, there will be a fixed response, right? Schemas will be fixed. But this MCP makes those servers AI enabled, right? So these are intelligent API servers, I can say, intelligent tool servers. They have intelligence of their own. So if something is missing, they can go back to the client and ask for it. So what the doc says, a growing list of pre-built integrations that your LLM can directly plug into, as we just saw. The flexibility to switch between LLM providers and vendors. So just now we saw that like you can easily plug MCP servers into different agentic systems, and it is not dependent on any LLM, right? So you can plug and play LLM providers and vendors also. Let's say you are working with GPT-4o, but tomorrow you feel that, hey, it's a bit costly and you want to change it with Gemini. You can easily do it, right? You don't have to recode your MCP servers or your tool calls, right? Best practices for securing your data within your infrastructure. So currently this whole MCP architecture runs the MCP servers locally, right? So it kind of increases the security of your data and your infrastructure, because most of these like MCP servers are running locally, right? Yeah, so this is the answer of why MCP. Okay. Next thing is general architecture. So let's see this general architecture in their official documentation. So at its core, MCP follows a client server architecture itself. At the end, it is client and server itself, where a host application can connect to multiple servers. So before we jump into this diagram, let me explain you over here what is happening, right? We have already seen this, but just for a revision, you will first of all have an MCP host, right? And this MCP host can have various MCP clients. You can have one MCP client, or you can have multiple MCP clients also. Okay, so I can say MCP client is over here, right? For example, MCP client can be your Claude desktop, Claude desktop. So just to show you when I am actually telling you, if I open my Claude desktop, it is over here. So this is my Claude desktop. Let's verify. Yes, it is opening up. So this is my Claude desktop. Okay. And as you can see, it is connected to some MCP tools. Basically this window where the end user is going to communicate with the agent or the LLM or the tools is called the MCP client, right? This can easily integrate with the MCP servers. Now you have understood what is an MCP client, right? It's the window where you can actually access the underlying MCP servers and the tools, right? Where you put your query. So MCP host, MCP Claude desktop, it can be cursor, right? Cursor, it's an ID, cursor ID. There also, you are using that MCP thing for software development, but there also at the end it can connect to GitHub MCP server. It can connect to any MCP server that you have running in your local. So cursor ID. Then we have Windsurf, or you can build your own custom MCP client also, which is there in the documentation how to do that. So first of all, you have an MCP host. Then you can have various MCP servers. You can have one MCP server, or you can have various MCP servers as per your requirement. MCP servers, right? Let's say you want to work with a local file system, right? You have some files in your system, in your computer. You want to work with that. That means when you write a query, hey, I have a file in my computers and I want to convert, or I want to read, you just read that file and give me a summary of it. So for that, you want your agent, you want your system to go to your local file. Normal LLM cannot do that, right? LLM, if you just open ChatGPT, it cannot access your local files. You have to upload a file. But using MCP, you can build systems that can do that. So you will have a MCP server, first MCP server that can connect to local file system, right? Then another MCP server can be for accessing your remote database or local database, right? So this is your database. It can be remote or it can be local. So one MCP server can handle this thing, right? Postgres, MongoDB. This MCP server will have all the implementation that is required to connect to a database, right? Then you can have some third-party tools, right? Some third-party tools. I tried to make a nut, but I was not able to. So third-party tools, right? So this one can connect to, this one can connect to this one. And you can have some custom MCP server which just have the logic. Let's say create a MCP server for compound interest calculation or for doing mathematics or addition, subtract, anything. You can have any logic inside it, right? So now your MCP client can connect to these MCP servers using MCP protocol. We'll come to the protocol, right? MCP protocol, and this whole system can work, and you can have an LLM over here, right? So at the end, I want to say that and tomorrow, let's say you don't want to work with remote database, you can just remove this MCP server. You can just switch it off. You can remove it from your integration, from your configuration file. That's it. And let's say you want to work with another MCP server. Without touching all of this, you can add another one and you can have another MCP server, right? So the complete logic is in this MCP servers, right? If tomorrow your API calls are changed, let's say GitHub changed their API calls. So you just have to go and fix over here. And all the MCP clients that were connected to, that were using GitHub, they don't have to worry about it because you just changed it. You changed the MCP server implementation. That's it. So this is the general architecture. You can see MCP client is over here, Claude, IDs, tools, then using MCP protocol, MCP, and yeah, it is a bidirectional. MCP server can also communicate with MCP client. It's a bidirectional connection, right? So MCP servers are there. One is for local database, another one can be a remote service. You can have any third-party service, and all of these are connected using normal API calls itself. HTTP is not going anywhere, right? So normal API calls itself, but it's kind of an abstraction on top of your tool calls, on top of your tool implementations, right? So what all components do we have? I think that's the next question. Yeah, MCP components. You have MCP host. Programs like Claude, desktop IDs, tools are your MCP host. MCP clients, protocol clients that contain one-on-one connection with the MCP servers. MCP servers are lightweight programs that each expose specific capability. One MCP server for one capability. Through the standardized model context protocol, local data sources, remote services, these are your components. Now what you have to do is, you can either go to the quick start and you can see how an MCP server is built and how a client is built. We'll come to that. But before that, you can go to this core architecture. This is much more important than directly going to the development. Okay, so what happens in core architecture? Let's follow this documentation itself. Understand how MCP clients servers connect and with the LLMs. The MCP is built on a flexible, extensible architecture that enables seamless communication between LLM applications like clients and integrations, servers and tools, right? This document covers that core architecture. We already saw we have clients, we have host, and we have servers, right? So MCP client and MCP server, host and the server, are communicating with each other in the transport layer. Like there is a transport layer, right? And then there is a protocol layer, right? So communication is built, right? Now for that you need to understand what is the protocol, because in HTTP you have a protocol which says that, hey, there will be in the client server architecture, you will have a request with content type, with body, with query parameters, right? So that's a protocol, right? Set of rules. Similarly for MCP, which is again another protocol, you will have some set of rules, right? So in the protocol layer, in the protocol, you have to define your request handler, right? So we have request, then we have a notification. Notification you already understand, right? When someone needs to notify some other component, you send a notification. So notification can be from server to client or client to server. So set notification. So all of these components have to be the part of your protocol, and they must be there in your server and the client, right? So request a handler, then set notification handler, then the actual request, which can have certain schema and the options, and then the actual notification, right? So key classes include the protocol, the client, and the server. So the transport layer handles the actual communication between the client and servers, and MCP supports multiple transport mechanisms. STD-IO, which is standard input output, and you have HTTP and SCC transport. So this STD-IO, which is standard input output, is very helpful or significant because they help in standard input and output transport when your servers are running locally. So ideal for local processes, because currently which is there, currently the system, most of these MCP servers, when you clone these MCP servers, they are going to run locally in your system. Okay, so STD-IO is very important, and HTTP and SSE, server sent events. You know, like ChatGPT also uses SSE. When you write a query and you hit enter, you see you get the response in parts, in tokens. Like, you know, like ChatGPT does not send you the complete response at once. It writes and sends you that response in parts. So that is possible using SSE, server sent events, right? So this is helpful when you are having this whole architecture running remotely. When your MCP server runs remotely, so then it becomes very helpful, right? So we have two types of transports. All transport uses JSON RPC 2.0, unlike LSP, Language Server Protocol, which uses JSON RPC 1. Exchange messages. See specification. You can read the specification of this RPC remote procedure call, and you can see that. But over here we have all the types of messages, because at the end you need to share messages, right? From client to server, MCP client to MCP server, you have to share messages and notifications in the form of request and results. So this is the type, this is the structure of that request, result, and notification and errors, right? So in the request, you will have a method, right? So as I told, you can share context, you can share prompt, right? So that method needs to be defined over here. Like, are you fetching a prompt? Are you sending a context? So all of that, we'll come to that, will be the part of this method. Then the parameters, you need to share data. So that will be in the form of parameters. Results. Results are successful responses to the request. Your client can send a request, you get a response back. So that's called the result. Errors. If something goes wrong, you need to send the error back. Code, message, and the data, right? Then the notifications. Again, notification has the same structure as the request, method, and the parameters. And this is how the connection looks like. You have the client, you have the server. First of all, client sends a request and server sends a response. As soon as this is done, a connection is built. You can also share notifications. Notifications are initialized. So basically you have to initialize this request, response, and notification. As soon as these three things are initialized, you can use them. Your connection is ready. Just like how WebSocket connects or normal HTTP makes a connection, right? You just need to initialize stuff and you are ready to, your connection is built. Okay, that's just a description of this. And then you can exchange messages, request and response, and notifications, either party, either a client can send a notification to server can send a notification to the client. Termination, at the end at some point in time you would like to close the connection, right? So that is called termination. Clean shutdown via close is a method. You can use that to close the connection. That disconnects the transport, and if anything goes wrong, then there can be an error condition. And these are some of the error codes: invalid request, method not found, invalid parameters, internal error, and these are the codes for it. Okay, like in normal connection HTTP, we have 500 for internal server, 404 for like not found, 400 for bad request. Like that in MCP also we have the codes, right? So if you're already coming from backend and computer science, you will find it very easy to understand. Now this is an example to build an MCP server. Here's a basic example of implementing an MCP server that we are going to see in further videos or further parts. Okay, so here's a basic example of implementing an MCP server. Okay, best practices. I think that this one I would like you to read, right? There is no point of me reading them on your behalf, because you will forget it. You are not understanding anything, right? So this best practices you will understand when you build an MCP server, when you build an MCP client, so that you can give it a read on your own. Okay, how to maintain security, how to prevent DDoS attacks, health checks, connection state, resource usage, because you have to see how much how many times you are calling the API. You have to reduce the API calls, right? So that all is a part of standard practices and debugging and all. Okay, next is your resources. Okay, so now we have seen the core architecture of MCP. Next thing is resources. So all of these things that you're seeing on the left hand side panel, right, they're the concepts of MCP. If you understand how these things work and how they communicate with each other, that's it. You have understood the MCP architecture. So next thing is resources. As the name defines, resource, that means something needs to be consumed, right? So resources actually expose that data and content from your servers to LLM. Servers means an MCP server, right? LLM at the end needs to consume something so that it can generate something, right? And that something will be called as context, because let's say you want to book a flight ticket. You want your agent to book a flight ticket. So the context will be when are you traveling, right? Which city you are traveling from and to, right? And what is your budget, right? So that actually is the data, right? And that data can be present anywhere. That can come from your database, that can come from your local file system, that can come from a local data source or a remote data source, right? Anywhere. And that needs to be given to the LLMs. Based on that data itself, LLM will be able to generate some response. So this resources actually expose that data and content. So resources are a core primitive in the MCP that allows servers to expose data and content that can be read by the clients and used as context for the LLM interactions. MCP client, that means your Claude desktop. There you are going to put that data, right? Or some query or some your task, right? Hey, I want to fly from this to this on this date, right? So that actually acts as a context to your LLM. But most of the times, or many of the times, your context will not be fulfilled by that query that you want to write in this chat box over here, right? So you will say that, hey, fetch the data from my Notion and create a social media strategy based on that content. So over here, you are asking the LLM to get the data from the Notion, right? So that Notion is acting as a remote data source, right? Or you can say that, hey, get the travel dates or travel document something from my file system, and based on that, look for the flights, right? So that's how your data can be present somewhere else, which needs to be given to the LLM, right? And that data, this whole thing, is called the resource that needs to be exposed to your agent. That is called resource. Okay. Resources represent any kind of data that the MCP server wants to make it available to the clients, right? To the LLMs, right? File content, database records, APIs, live system data, screenshots, images, log files, and many more. So all of these are resources which needs to be given to the LLM for coming to a decision, right? And every resource is identified by a unique URI. So every resource that you want to give to your MCP server will have a location, right? For a file system, it can look something like this, file, that means the protocol, and then the location of that file, right? Similarly, if it is a Postgres, then Postgres database customers / schema, right? Like screen, if you want your agent to control your computer, then you need to expose your screen, right? So screen will be the resource for the LLM. So screen slash localhost slash display one, because you can have multiple displays in your computer. So which display you want to give access. So this is the resource. These are the paths of the resource. Okay. Then we have protocol and path structure. Yes, that is correct. Two types of resource types. Text resources like source code, right? Configuration files, log files, JSON, XML, plain text. Binary mein, you will have images, PDFs, audio files, video files, or any non-text formats, right? So these are the types of resources that your agent can consume. Next thing, I think they are showing the direct resources and resource templates, because you can either expose your resource directly. Hey, this is the URL, this is the path of my resource, this is a name. You can give any name, any human readable name, some description so that you can actually understand it later when you will be reading the code. And the MIME type. MIME type actually defines the file type like PDF or PNG or JPG, right? So that comes in the MIME type. Or you can also expose your resource as a template so that you can reuse it again and again. So your template path, URI template following the RFC 6570. I am also a bit confused over here. So as I'll be exploring more in the coming days, I will be making more content or LinkedIn post around these stuff. Okay. Name and description and the MIME type. So two ways of exposing your resources. One is direct resources and another can be resource templates. Reading the resources. So to read a resource, clients make a resource/read request with the resource URI, because at the end you need to read your resource, right? That resource can be read by the client and can be server also. Okay. So let's say client wants to read that resource. So server is going to respond with the list of resources. Okay. So URI MIME type text blob. If it is a file, if it is a PDF, then blob will be there. If it is a textual resource, then text will be there. Very simple, right? And now at this point of time, the significance of notification you can see. So let's say you have your Notion, right? Now let's say you made some changes on the Notion. Now your client does not know about that. So that needs to be sent to your client so that your client can now be updated with the information or the context. So at that point of time, your server can send a notification to the subscribed clients, right? So you can read over here, content changes. Clients can subscribe to updates for specific resources. Client needs resources/subscribe with resource URI so that it can subscribe to that resource. Server sends the notification that, hey, this resource has been updated, right? And that's it. So that's how your updates can also be notified, can also be sent to your client via notifications. And this is an example that you can read. First of all, you define the server. This is a MCP server, right? So first of all, you define an MCP server. Then you are going to list your available resources that your server has access to. So you are again going to use set request handler. Then over here, you are saying resources list, URI name MIME type. Then again, URI name MIME type, URI name MIME type. So list of resources. Then read resource content. So if some client wants to read it, then you are going to say whatever URI the client is going to send. Then you are going to say if this URI matches the path, then you are going to send that response. You are going to return that as a response, the contents, right? And if something goes wrong, you can throw an error, just like normal exception handling. And this best practice is up to you. You can read it. Next is prompt. So resources, we saw that, hey, resources are your data sources or your third-party API services, which are very significant for your LLMs, right? Next is prompts. So just like any prompt template. So if you have already worked with LangChain, right? So there also you create prompt template and there you can pass the arguments. So similarly over here also, when you create a prompt template, you can pass dynamic arguments. You can include context and resources. You can chain multiple interactions also, right? Guide specific workflows and surface as UI elements like slash commands and all, right? We already have worked with these commands. Prompt structure. Okay, so this is how the prompt is defined in the MCP server. Name, unique identifier, it is given by the human so that it is so that anyone can understand it later. Description of that prompt, arguments. So there are three arguments in this: name, description, and required. So this is how you define a prompt in the MCP server. And there are some examples, right? So some list of prompts. So basically this is a request, because from the client a request will be sent to the server. And let's say you want to fetch your prompts. So this will be the method. As I told, in HTTP you have get, post, put, delete and all. In MCP, for MCP protocol also you have some methods, right? So this is a method for listing all your prompts, and this is your response. So you get a list of prompts. So this is your one prompt, name, description and the argument. That the way you saved it, in the same way you're going to get it. Okay. And you can again use these prompts. You can pass arguments. So dynamic prompts, you can pass arguments. That prompt will become dynamic. Prompt get means you want to get your prompts. So these are just the methods. So you can give it a lighter read and you will understand it very easily. Or when we will be seeing an MCP server, there also we can I can show it to you. Next is tools, which we already know. If you want to perform an action in the agentic environment, you need tools, right? So we won't be going deeper into this because you all understand what is a tool. Similarly, in MCP server also, an MCP protocol, MCP server also is connected to various tools for various actions, right? So this is all theoretical part. Let's see that. Yeah, let's see the definition of tool definition in the MCP server. Define the name, description. So I think these are just common for all resources and prompts also. So name and description and the input schema. So your tool will be like a function. That let's say that tool performs or calculates the compound interest. So what you need? You need principal, you need time, you need rate of interest, right? Half yearly or annually, right? All of that. A number of half years, something like that. So they will be properties. They will be arguments. So they will come in this input schema. That's it. That's it. Okay. So this is how you define your tool. Implementing the tool, again, you define a server in the MCP server, and then you again define set request handler. You say tools. Previously you are saying prompts. Okay. Previous to that you are saying resources. So now this is tools. So again, list of tools. This tool calculates the sum. So this is a normal function that calculates the sum of two numbers. So you need two numbers, A and B. So you take those in the properties. And then these two are required. So A and B are required. And then you say local tool execution. You again say set request handler. And then you say if my request or parameter name, that means if my function name is calculate sum, then you actually define the logic of that function over here. Okay. So you get A and B in the arguments. And then you actually return A plus B, string of A plus B. Right. That's it. Okay. So this is how. So this is a very simple example. If you want to calculate compound interest, then you will write the compound interest formula over here. You can calculate it over here and return it over here, right? If you want to perform some encryption or some any kind of logical thing, you can do it over here and you can return the response. So this is how tools work, right? Similarly, we just saw some logical implementation of a tool. Let's say you want to make an API call. So yeah, similarly, you will define your API call over here, right? You're going to define your over here. You can see GitHub create issue. So this tool actually creates an issue on the GitHub. So you need to go to the GitHub using GitHub API. So you're going to write the API call implementation in that tool call. That's it. You define the properties. You will need the description of that issue. You need the assignee of that issue, right? You need the title of that issue and deadline of that issue. Make an API call. That's it. Okay. So that's how tools work. Similarly, if you want to save your data in a Postgres or MongoDB and you need a tool for that, you can create a tool for that. Okay. So over here, this example actually analyzes a CSV file. It finds a sum, average, count, and it can perform those actions. So at the end, it's just the code, Python, normal logical code, right? Which is wrapped in the form of a tool so that agents can access those tools. That's it. So what is sampling? So most of the times, as I told before also, your servers will also need some generations from the LLM, some inferences from the LLMs, because all of these servers are AI enabled, as I told. So that means these servers can get some data from the LLMs. That means they need completions from the LLMs. So sampling actually helps those MCP servers do that. So sampling is a powerful MCP feature that allows servers to request LLM completions through the client. So these servers are going to communicate with the LLM through the MCP client, which is your Claude desktop, because Claude desktop is connected to an LLM, which is Claude 3.5, 3.7 Sonnet or Haiku, any model, right? So these servers can, as I told, this connection between client and server is a bidirectional. So servers can also send data to client and they can also request some data from the client, which is over here the completion from the LLM. So sampling is a powerful MCP feature that allows servers to request LLM completions through the client, enabling sophisticated agentic behaviors while maintaining security and privacy. Okay. This feature of MCP is not supported in the Claude desktop client. This feature is not yet there in MCP. I give you the example of Claude desktop, but mostly it will come in the future. Okay. How sampling works? Sampling follow the following steps. First of all, server sends a sampling/create message. Again, this is like a method, right? So if you want to get prompt, so prompt/list, that method can be there. Similarly, if you want get a completion from the LLM, this will be your method, where the method name starts with sampling. Okay. Client reviews the request and can modify it. Client samples from the LLM, client reviews the completion, and client returns the result to the server. So you can see in normal HTTP connection what happens. Client requests the data from server and server sends a response. But in MCP, this is bidirectional. Server is requesting some data from the LLM via the client, and client is sending the response back to the server after checking it. So in HTTP servers, there is no checking. Whatever data is received, send it to the server or send it to the client. But over here, because these are intelligent systems, they are connected to the LLMs, they can do a review on their own. And below is the complete message format. Like you have messages, as you have in like when you make a call to the LLM, you have users, role, you have roles, and you have the content. Similarly, you have them over here. You can send MIME type. That means you can send a file also. You can send an image also, right? Yeah. So I think this you can give it a read, like what exactly is happening in the sampling. But overall, it just helps the server to get a completion from the LLM. Next is routes. So basically, with the help of the routes, clients can suggest the server which all file paths the server should work with, right? Or which all file paths server should not work with. Or let's say this was the local example. Now let's say for the HTTP. So these are the URLs which server should try getting the data from with the required or the necessary tool, right? Or these are the URIs that might be helpful for the server to get the data from, right? So routes just help to define that boundary. Okay. Routes serve several important purposes. Guidance. They inform servers about the relevant resources and the locations. Clarity. Routes make it clear that which resources are a part of your workspace. Let's say there is another workspace also in your computer and you don't want to give your MCP access to that. So using routes, you can do that. You can make it very clear for the server like the boundary in which the server should work. Next is the transports. Transports just help in communication, right? They are just like a communication mechanism, as they are saying in the first line also. MCP's communication mechanism. So transports in the MCP provide the foundation for communication between the client and the servers. Right. So these two are two separate entities, two separate components, and they need to communicate with each other, right? And transport helps do that. So as I told, MCP uses JSON RPC 2.0, right? While LSP or the other the LSP protocol uses JSON RPC, not the 2.0 version, right? So MCP uses JSON RPC 2.0. The transport layer is responsible for converting MCP protocol messages into JSON RPC format for transmission and converting received RPC messages back to the MCP protocol messages. Now, because we have to work with messages between client and server, and we already know we have three types of messages. One, when client sends a request to the MCP server. So that's a request, and you can see it over here. So it will have JSON RPC version 2.0, ID, whether it's a number or string. Then like ID can be in number format or string format, then method and the parameters. That is going to contain the data that needs to be sent from client to server. Now, once the server receives it and server does something and needs to send the response back to the client, then it will be a response message. So again, JSON RPC version, ID, same ID, the result that a server has gathered via tool call, right? Then if there is any error, so it is nullable. You can see error is nullable. Okay. And notification, as I told that client can send a notification to server can send a notification to the client. So that will be there in this. So it is very small, JSON RPC version, method, and the parameters of that notification. Okay. So we have there are two built-in transport types, right? One is STDIO, standard input output. STDIO transport enables communication through standard input and output streams, right? This is helpful when you are working with a local integration, like your local file system, right? As it is saying over here, use STDIO when building command line tools, because let's say you want to create a CLI that has access to an LLM, that has access to your local file system, that has access to GitHub, Slack, Notion, or any third-party tool. So that whole system is like an agent, and that should be AI enabled. So you can easily use MCP for that. And because it will have a lot of local permissions, local file accesses, then you can use STDIO for that. Similarly, if you're working with a remote resource, then for that you can use HTTP or SSE. Okay. Implementing local integrations, needing simple process communication, working with shell scripts. Great. This is an example of like working with STDIO. So create a server. You can see a server is created. Define a transport and connect connect to the server, like server.connect to that transport, via that transport or through that transport. Okay, so I think, yeah, this makes sense. And next thing is SSE, which is useful when you're working with a remote service. So SSE transport enables server to client streaming. So what happens, just an example, in ChatGPT, when you write something, you get some data in tokens, you get some data in parts, right? You don't get the complete answer at once. So in that case, what is happening, your server, as soon as server receives a inference generation from the LLM, it quickly sends it to the client. So that client, the user, does not have to wait for the complete inference. Instead of that, it can, see some responses that are generated. So in that case, your server is streaming the response, generated components, generated part of the response back to the client. So this is useful in many cases, right? So SSE transport enables server to client streaming via HTTP post request, their post request itself, for client to server communication. Okay. Use SSE when only server to client streaming is needed, working with restricted networks and implementing simple updates. And here is an example. You are just defining a simple, call to this endpoint /SSE, and this is a transport, SSE server transport. This is again coming from the MCP itself, okay? And server.connect via this transport. So you have two types of transport basically. One is your STDIO and next is the HTTP SSE, okay? And I think this is a simple Express server, yeah. And you can also see the Python server. Both Python and TypeScript supports SSE. Okay, and yeah, you can have your own custom transport, but this will be too much for this video. Yeah, I think we have covered all the concepts on a high level. Cool. So now you can actually come to quick start and go to for server builders, server developers. So as I told, in MCP you have two main components. One is your MCP client and one is your MCP server. And as a software developer, you can actually build both. Okay, server. MCP server, most of the companies who are, who already have API servers, who already have APIs out in the market, they have started building MCP servers, okay, which are like a wrapper on top of their API servers, right? Like OpenAI released their MCP server, GitHub, Slack, Notion also have their MCP servers. Not sure like if they are like official, but developers have built the MCP servers for GitHub, Notion, Slack. And if you want to see, right, if you want to see which all servers, MCP servers are already there in open source, and one of them we are going to use today and in this video itself, and I'm going to show you how MCP clients work with MCP servers. Just in a minute, I'm going to show to you. But for that, you can actually go to this repository, model GitHub servers. Yes, this is the repository, model context protocol /servers, right? So in this, if you see this README, we have MCP server from AWS, Brave Search, some common one, yeah, GitHub, GitLab, Google Drive, Google Maps, Postgres, Puppeteer, Redis, Sentry, Slack, SQLite. You can see browser base, ChromaDB, ClickHouse, Make.com, very famous, Perplexity, Zapier. So all of these MCP servers are already built and the code is live. We have a Figma MCP server also. Okay. So first of all, if I show you an example, let's search for Notion MCP server because I'm going to use that in this video. So what we are going to do is, you can see my Claude desktop right over here, right? So if I say, hey, can you write a marketing strategy for me? Can you create a marketing strategy for me for this company in Notion, right? Now you know that LLM does not have access to your Notion, right? It is not authenticated, right? But using MCP, this client, MCP client, this is your MCP client, right? Can communicate with the Notion MCP server, which is further connected to your own Notion using the API key, using the Notion API key. And because of this whole connection, your MCP client can directly write on Notion, okay? It can write the content on Notion. So this is like one example. Next, a project which can be that, hey, on this Claude, I'm going to write, fetch this product info from Amazon.com. So using Perplexity, because Perplexity has internet access, using Perplexity will fetch the product information from the Amazon, and based on that product reviews and cost and features, ingredients, everything, it can write a personal blog for you on Notion, right? So you can see your LLM has got the power of Perplexity, then Amazon.com website, and this Notion also. So this can act as an autonomous agent, right? So we are going to work in this video itself, don't worry. So you can see we have two Notion MCP servers from different developers. So if I go to the second one, and you can see this is the code for that MCP server. So this is the code of MCP server, okay? So Notion MCP server that provides seamless integration with Notion. It enables language models to interact with your Notion workspace. Okay, so we are going to fetch an API key, and we are going to run this MCP server on our local. So we're going to pull it and run it on our local, and it is going to, it will be configured in my MCP client. Okay, then the whole architecture will be ready. So if I just show you the code of this server, okay, index.ts, we only have one file. So over here you can see I'm just creating a Notion object. So if I just increase the font size, right? So using the API key, I'm just creating a Notion client, right? And then I'm defining some schemas like Notion title, Notion page, because in Notion we have multiple pages. I hope you have worked with Notion before, okay? You have some Notion pages, and then you have some tool inputs, like if you want to search a page, read a page, create a page, update a page. So all of these types are created first of all, right? So that schemas are ready. And after that only the real thing will be there to push data or read data from Notion. This is a bit of formatting the errors so that your client can get it. What's the issue? Tool definition. So we have various tools, and over here you are just defining the tools. So one, you will have search pages, because what will happen when I was trying this before, I told my MCP client to create a marketing strategy for a company. Let's say the company name was like anything, ABC company, right? So what my tool did, my MCP server did, it first searched in the Notion for any pages related to that, so that it can write it there itself. So this tool is necessary for searching the pages in Notion. So search page, then you definitely have to read the page, so that if some content is already there on the page, what is that content? So reading the page, then creating the page. New pages can also create, like servers can create new pages also. Creating the page, updating the page, retrieving the comments on that page so that you can fix it. Your MCP, your agent can fix those comments. Adding the comment. Let's say you asked your agent to go ahead and review this plan, review this strategy on Notion, and then your agent can actually write comments on that content. It is super cool, right? You don't have to review the content. Your agent can review the content on behalf of you. So add comment tool will be there. Creating a database tool will be there. Querying a database tool will be there. So all of the Notion tasks are actually put in the form of a tool, right? And now you're actually writing the tool calls. So tool handlers, search pages. This is a like a function for searching the pages in Notion, right? So Notion client you created at the top itself, and using the Notion SDK for TypeScript, you can actually search the pages, and in the response you will get those pages. That's it. So at the end you are doing API calls itself. In this Notion SDK for TypeScript, you are at the end doing the API call itself, right? But as an agent builder, I don't have to worry about this, because this is an open source MCP server. I can pull it, I can work with it. Okay. Within 10 minutes, I'll be showing you how to let your agent talk to Notion using MCP. Within 10 minutes, because of these open source MCP servers. And at the end, if you will go through this MCP server code, and if you have already worked with TypeScript, you will not find any difficulty in understanding this code. This is just TypeScript, and just the format of writing the code is in the format that we just saw in the documentation. That hey, you need to define your tools, you need to define your request handler, notification, creating a server, running the server. That's it. Okay, that's it. Again, just the API implementation, logic implementation. Retrieving the comments. Yeah, I think this is easy. And at the end, exception handling is there. The main function is there. Yes, you can see at the end, this is important. So in the end, for this MCP server, you're defining the object for the transport. I'm using stdio. Like in this, the developer is using stdio. Connect via the transport. And if anything goes wrong, you can console the error, log the error. That's it. Server.connect. As soon as you do that, your server is ready to be consumed. So this is a simple server. Similarly, go ahead on GitHub, go to this repository and read MCP servers. See how they are developed, so that when you have to build your own custom MCP server, you can do that. Let's see one more and then we can go ahead and implement this MCP server practically. Like, I mean, not coding the MCP server, that will come in the further videos, but we're going to use this open source MCP server to talk to Notion. Okay, let's see MCP server for GitHub. Okay, so this is an MCP server for interacting with GitHub Actions. So let's go inside it. Again, I'll be showing you how to work with these. The process is kind of same for all of these MCP servers. Go to the source, go to the index.ts, and over here you can see some errors like are defined so that you can actually log those messages. Then you can see again server.setRequestHandler. The format is same. We have already seen this in the documentation, right? You define setRequestHandler and then you define all the tools, right? So these are the tools: list the workflows, get the workflow usage. So if you have already worked with GitHub Actions, these are the terminologies and nomenclature, simple nomenclature. You'll understand it if you have already worked with CI/CD pipelines in GitHub Actions, right? Then again, set request handler. At this point of time, you are defining your request, working with the request, right? So if your request, you get the parameters. If your request is for, so just as a simple switch case, if your request is for listing the workflows, you have created you are using the GitHub Actions SDK for TypeScript, and you're just listing the workflows and sending the data back to the client. That's it. At the end, you're just using SDKs, right? In the format of the MCP protocol structure, MCP server structure. So let's get back to our documentation. So as I told, we have two options. Either we can build an MCP server or we can build an MCP client. Now, before we go and read this documentation, let's build something, and automatically this documentation will be covered. Okay, so what I want to build is, if you see over here, I have this Notion page in front of me, right? So what I want is, and I also have an MCP client running in front of me. Claude Desktop is just like an MCP client itself, right? So let's assume that there is a MCP client that we are using, which is already built. You can build on your own if you want, but the one that we are going to build, that will also have some kind of chat window itself. So you have an MCP client over here, and we have a third-party service opened in front of me, right? Notion. So what I want is, what is my target is, I want to write something over here, right? Let's say, hey, can you create a social media calendar for my company? And it is going to generate it. That we already know. If you have already working with ChatGPT or any other chat window, LLM window, then you already know it can generate it. But what I want at the end is, it should create that social media calendar on Notion, because my company uses Notion and everyone in my team uses Notion, right? So I want my chat window to be connected to Notion in some way. And yes, you can build your own custom agent and you can do it. You can use Notion APIs to do it for you. You can create tools for your agent. But at the end, we want to do it using MCP, which will be very simple, and within 10 minutes we can do it. Okay, so let's do that. So first of all, I have to use an MCP server for this. So first of all, I have to run a Notion MCP server in my system. So I'll get back to the documentation I'll get back to this repository where all the MCP servers are there. And because I have to work with Notion MCP server, I will select one of the Notion MCP servers. Code of this server we already know, and I'm going to clone it. So I'll just copy this path, and I'm going to open my terminal. So here is my terminal, and in this terminal, as you can see in the documents, and I created this folder. In this folder, I'm going to clone that MCP server code, which community has already built, right? So I'll paste that line and I'll hit it. I think there is some issue. Let me do it again. Let me just paste it. Okay, just a second. Git clone. Yes, it is cloning now. So this will clone the complete code. If I just get inside this server, and if I say ls-a, so it is going to tell me what is there inside that piece, like in that repository, right? So I have this complete source folder, and I need to build this folder. So first of all, I'll install all the packages, npm install, and then I'll say npm. Before that, let's read the documentation, and let's check the documentation once. So you just have to follow the readme file of that MCP server. Whether you are working with any MCP server, you have to just follow this readme file. So we cloned the MCP server. This is done. We did npm install. This is done. Now I need the Notion API key. So for that, you need to go on your Notion, right? And go to settings. You can see settings over here. Go to settings, and inside the settings, go to connections. And inside this connection, you go to develop or manage integrations. So I'm doing this to get the Notion API key. Okay. And over here, you can see integrations. So click on new integration and let's call it as MCP test integration, right? You can name it anything. And I'm going to select my space. You can have multiple workspaces in the Notion. I want to work with Akshit space. And internal, you can have a logo, right? And let's click on save. So this is done. As soon as you do that, configure integration settings, and this token you're going to get. So make sure you get your own token because this one I'm going to delete it, copy it. And if you use my token, your data will come into my Notion, not in your Notion. Okay. So just copy this token. Let's see the documentation, and we need to export this as Notion API key. So I'll go back to my terminal and I'll say export Notion API key is equal to, paste it and hit enter. Yes, so this is done. What is the next step? It is to build the server, npm run build. So let's do that. Great, so you have built the server also. Now this is done. Let's see the next step. Yes, so now we need to edit our Claude desktop. That means you have to integrate this MCP server, or you have to make the connection between your MCP server and the MCP client. So MCP server is ready. It is built and it can run in your local system. That is all set, right? Now you need to work with the MCP client. So as I told, you have two components, MCP client, MCP server, and then you have third-party service. Now what you have done is you have allowed your third-party service to get integrated with the MCP server using the API key. We provided MCP server the Notion API key. That part is done. Now what you have to do is you have to connect your MCP server and the MCP client. So for that, you have to just copy this piece of code, which is for configuration, and get back to your MCP client, which is your Claude desktop. Over here, click on Claude settings, developer, edit config. So you can see this file, open with your favorite ID. Let's say I use cursor, or you can open with VS Code, open it up and paste, remove everything inside it and paste it. So what it is saying is that you are going to have these MCP servers for that MCP client. And first MCP server is Notion. This is the name of that MCP server. Okay. Command is node so that you can trigger that MCP server and run it. And you have to provide the path of your index.js file. So get back to your terminal and let's open this in a ID. So for that, I'm going to say cursor dot, or you can say code dot if you're using VS Code. Hit enter and it's going to open that MCP server in a ID. So inside this build, you can see index.js. Right click on it and copy the path. Get back to your Claude desktop configuration file and paste that over here. Right, so this is done. And again, you need to paste your Notion API key. So let's bring it back from Safari, then my Notion, and let's just copy it and let's just paste it over here. Okay, so this is done. Save it and you can close it, and you can also close this, and you can also close this one. Okay, so this is done. Now configuration is ready. Now you have to close Claude once and you have to open Claude again. Okay, as soon as it is opened, click on Claude, again open settings and open developer. You can see Notion is over here and it is running, right? Because it has got the path of your index.js file, and these are some advanced option. Notion API key is over here, nothing else. Okay, so now my MCP client has got the access to MCP server. MCP client has got access to MCP server. It can communicate with Notion MCP server. Like this, if you are working with, if you want to give your MCP client or your LLM power of internet, so you can similarly do the same process and bring Perplexity MCP server in it. Perplexity MCP server is also there in that repository. Bring that. Right? If you want to work with Google Drive, bring Google Drive MCP server over here. Right? Make that list. You can work with approximately 90 to 100 tools with one MCP client. If you increase that, your model might get confused. It might hallucinate. Right? So 90 to 100 tools you can easily work with. So go ahead. Depends on your agent and depends on your project. Now click on File, New Configuration. As soon as you do that, you're going to see this Tools button over here. And you can see all the functions that are there in the Notion MCP server. They are listed over here, right? You can read all the properties of these functions. Great. Now I'm going to connect this Notion and MCP client in one window. I'm going to close this. And one more setting you need to do in your Notion. So what I'm going to do is I have created one page in Notion, ABC Media Agency Social Media Calendar. Over here, I'm going to say, hey, I run an agency called ABC Media, and we make content around tech, developer relations, developer advocacy, and AI, blockchain, and all. Prepare a social media calendar for me on my Notion, not over here, in this Notion directly, right? And like within a week, I want to post around all of these topics. So it should create a social media calendar directly on my Notion, not in the client. Okay, but before that, you can see this menu icon. Click on that and click on connections, right? Or you can search connections over here, connections. Click on this connections and you need to search for the connection that you created. We created MCP test integration, if you remember, over here. Click on it and confirm it. So now that connection is integrated into this Notion page or into this Notion workspace. That's it. Now I can write my prompt. So let me write it. So this is the prompt that I've written. Prepare a social media calendar for my social media agency, ABC Media, which creates content around tech, developer relations, news from tech giants and tech billionaires. We post on LinkedIn, Instagram and Twitter. Create a balanced social media calendar on Notion. We are a new agency and create text posts, reels, tweets and videos. Create this calendar on my Notion. Okay, so this is the prompt that I've created, and automatically it should see if it has access to MCP server of Notion, and in that what all available functions are there, and then it should get this page and start writing on this page. Let's hit enter. And I'm using Claude 3.7 Sonnet. Okay, it has started the work. I'll help you create a social media calendar. Now you can see it is asking me to allow the tool call from Notion local. Okay, Notion MCP server is running in my local currently, and I'll allow for this chat. Now it is continuing the work, and it is again asking the permission. Let's allow it. It has found the page ID, ABC Media Agency Social Media Calendar. It found this page from the Notion. Okay, so it has already found it. I'll allow it, and now it is preparing the content which is going to put in this page itself directly. You can see automatically it has created this complete social media overview, then strategy, then posting schedule. It is now trying to create. Now it is creating some content categories. Okay, let's see what it creates. I mean, it can actually act as a draft for me and I can improve it anytime, but this is a good one. I don't have to go and this is just I'm just using one MCP server. Just imagine if you have 100 MCP servers running and your Claude desktop has access to all of those. Literally, you don't have to move away from this MCP client at Claude desktop. From here itself, it can act as a Jarvis, it can act as a super admin panel for you. And from here itself, you can control your Notion, you can control Google Drive, you can control your Sheets, Docs, anything, GitHub, Slack, anything you can control from here itself, right? So this is so cool. Okay, I think it is still working on it. Let it create. It is still doing, it is creating multiple pages. It is populating this weekly content calendar. Let's see what it has. So I can see the posting schedule, 3 to 4 posts per week for LinkedIn, 4 to 5 posts per week for Instagram, and daily posts for Twitter. Makes sense. And let me go inside this content categories. So it has created this wonderful table for community engagement. It is saying poll, question, text post. Then it is saying tech memes and humor, tech trends and analysis. So it is just dividing this whole content like into some categories, right? For tech tutorials and how-tos, you have reels, shorts, videos, infographics. Amazing. This is really, really helpful. Let me see this weekly content calendar, and like it has actually put the complete content, then categories, then content types, then days on which you have to post, then the notes for each topic, then platform on which you have to post, then status. I mean, this is really helpful. I think I'll be using it for my own social media. Really, really helpful. And it is still doing, and it has hit the limit. That is fine. You can just say continue and it continues the work. I mean, this is so cool. Using MCP, I mean, really reduce the work. Great. Awesome. So this was how you can actually work with open source MCP servers, which are already available on GitHub, and you can check this repository. You will love it. Okay, so you just saw that how MCP servers and MCP clients can interact, and they can call the third-party services. For now, we use a third-party API service. Similarly, as you can see in this general architecture, we currently work with a remote service of Notion. Similarly, you can like clone a MCP server for controlling your local file system Similarly, you can do it for controlling a database, MongoDB, Postgres, anything. And it is totally up to you. If you have a local database, you can also have it for that purpose. I mean, yeah. After this, I would suggest you to go ahead and read the server developers. I mean, we already did this. We already went through the Notion MCP server code also. We did everything. We created we actually cloned it. We did not create our own MCP server. But in the further videos, I'll actually teach you how to create custom MCP servers. I don't want to like extend this video. I would like it to keep it to 1 hour itself. But actually, if you read these codes of MCP servers, you will find all of these things also. Okay, at the end, you're just creating a node server. But at the end you are having the set of rules for MCP, like the protocol is MCP, so you are following those set of rules instead of following the set of rules as if you are creating a typical server. Okay, so yeah, I think that's it. Similarly, we did all of this. We already saw how to see the available tools, how to connect using configuration file in Cloud Desktop. Yeah, I think this is it for server developers. Similarly, like this was a server, right? Similarly, as you have a window for the MCP client, just like Cloud Desktop, you can create your own custom window also, right? And that custom window does not always have to be a UI. You can also have an MCP client as your terminal CLI, right? On your CLI, you can also type something that, hey, connect to Notion and put this content over there. So that can also act as an MCP client. Okay, MCP client just means taking input from the end users, right? And that can be in any form. Okay, so I think that also you can do it simply using Node.js or Python, anything, right? And this is a structure of creating an MCP client. You first of all create an MCP client, and then you write down all the protocol functions like connect to server, then listing all the available tools, processing a query. Then the main thing will be here in your MCP client, you will have your LLM connected. So over here you can see you are actually fetching the response from the LLM. And based on the response, you have to decide whether to do a tool call or definitely all of these tool parameters and function names will go to their LLM. And if there is a requirement of a tool call, LLM will guide you that you have to make a tool call. But you have to fetch that response part and you have to check which tool to call and what all parameters should go inside that tool call. So that have to be that you have to code, right? So yeah, I think then you will be just creating a chat interface, mainly just like a chat window. Yeah, that's it. Rest all is the theory. So over here, I think the person has created a CLI list of a connect to specified server. No, I think this is a normal client itself. And then you just have the best practices. So overall, we actually, and there are some example servers and example clients we already saw on like GitHub. You already have those servers in front of you in the GitHub repository. So there are some tutorials that you can check, but overall we covered this main part of this documentation. Then you have some SDKs, like if you are working with Python, then you can have MCP SDK for Python. Similarly for TypeScript, Java, Kotlin, C#, and you can create your own custom also. Let's say you want to create a SDK for Swift or let's say Dart, then you feel free to do it, right? I think we have covered everything. I hope you enjoyed this video. I actually showed you how to work with an MCP server and MCP client also. Apart from everything that we covered, if you feel that, and definitely I will be pushing more videos around creating custom MCP clients and custom MCP servers. But apart from that, if you feel that you are confused in this topic around MCP, let me know. I'll be happy to create a tutorial. Just put that in the comment section. The next video on MCP will come as soon as I get around 200 likes on this video. And yeah, if you have any doubt, do feel free to reach out to me on LinkedIn. And my TopMate link is also in the description if you want to have a one-on-one video conversation with me. Yeah, I think that's it. Till the next video, keep coding, keep innovating, and thanks a lot.